All right, hey guys, let's just go ahead and talk through lesson 4 for today since I am not there. So I'll just explain what's going on in here. I want you guys to fill out the stuff in your workbook. And also we will get to a point where we're just doing stuff out of the workbook. So it might be beneficial for you to use a separate sheet of paper for that extra practice. I promise. I very much promise it will be helpful for your homework quiz. So for the warm-up, basically there's only two things to notice here. One is the fact that they're just working with 7s and 9s, and the other is the fact that we've used all 4 operations. So we're just going to go ahead and move on. Okay, so there's just these statements, and we want to think about whether they're true or whether they're false. If you add 2 even numbers, will you always get an even number? Yes, this is true. Right, I mean, 4 plus 4 is 8, 2 plus 6 is 8, I don't know, 10 plus 12 is 22. You will always end up with an even number. Similarly, if you subtract even numbers from each other, you'll also always end up with an even number. If you add 2 odd numbers, will you always get an odd number? I don't know, let's try it. 3 plus 5, those are 2 odd numbers. We actually got an even number. So this is false. This is fake news. 4, if you subtract an odd number from another odd number, you'll always get an odd number. Similarly to number 3, we actually always get evens with this one as well. Wow, my handwriting is really ugly on this thing. I was much better when I got used to it and was teaching online. If you multiply 2 evens, you'll always get an even number. This is true. It kind of makes sense because when a number is even, that means it's divisible by 2. 2 is a factor, so if you just multiply 2 of them together, you'll always still have 2 as a factor. So if you multiply 2 odd numbers, will you always have an odd number? This is true, because if you were never divisible by 2 and then you multiplied by another number that was never divisible by 2, that's just not going to ever help you be even. You won't ever be able to be divided by 2 at that point. If you multiply 2 integers, you'll always get an integer. That's true. Guys, an integer is just a positive or negative whole number, so like no decimals. If you add 2 integers, you'll always get an integer. That's true. And if you subtract them from each other, you'll always get an integer as well. This is also true. Let's see. If you add 2 rational numbers, you'll always get a rational number. This is true. And a rational number is a number that you can represent as a fraction, basically. If you can divide 2 integers and get a number from it, that number is rational. If you multiply 2 rationals, will you always get a rational? That is true. And the same goes for division. Lovely. Okay, so moving on to working now with polynomials. We're kind of now getting into the idea of, instead of thinking about combining just regular numbers, we're going to combine polynomials. And it's really important for us to think about what a polynomial is. In this curriculum, a polynomial basically is just any old string of terms. It can even just be one term, as long as there's like x's in it, and no negative or decimal exponents. So an example of a polynomial, we've seen plenty of them already, like x squared plus 4x minus 2. That's a polynomial. X cubed plus 1, that's a polynomial. Even 4x minus 3, that's a polynomial, okay? These are all just random examples. So we're just going to go ahead and glaze over this real quick. We will get polynomials when we combine polynomials, just like the whole idea of combining integers to get integers. So let's just go ahead and practice combining some polynomials, because I think that's going to be the most helpful. So if you are adding 2 polynomials, you are basically just going to combine like terms. With addition, we don't even need to really pay attention to the parentheses, because with addition, order doesn't even matter. So these guys will combine, and these 2 numbers will combine. So 4 and 3 make 7x, and then 2 and 1 makes 3. So this is what you get. Over here, it looks more complicated, but it's not really. This is still addition, so honestly, I could just go ahead and add the like terms together. 3x squared and 1x squared, that's 4x squared. And then 5x plus 2x, I guess I can double underline those though. That's going to give us 7x. And then negative 6 and negative 3, right? Think about adding two negatives together. That's going to give us a negative 9. So that is our answer for when we combine these. Here we have some subtraction, so you have to be careful. Because this is a minus sign before this polynomial, it's going to change the signs of everything inside of those parentheses. So we're going to rewrite this as a minus x and a minus 1. So now we can combine like terms again. 2x minus x, that leaves us with 1x. And then negative 4 minus 1, that leaves us with a negative 5. You just get more negative. All right, and now we are in the multiplication portion of this. This is going to be super important. This is also a skill you learned in Algebra 1. I would like for us to use the box method. Yikes, that's horrible. I'm just going to use the straight line tool because I'm not trying to play around with this. Let's use blue. Okay. Okay, so making a box. Sorry, this is disastrous. At this point, I'm totally in a rush because of my flight tomorrow and stuff. And I have not yet left Champaign, so love that for me. Just rambling. Okay, so 2x minus 6 and then 3x plus 4. This is how we set up multiplication using the box. So 3x times 2x is 6x squared. Notice how when I multiplied 2x's, I had to get a squared term. Negative 6 times 3x is negative 18x. And then 2x and 4 is 8x. And then negative 6 and 4 is negative 24. Then you combine like terms. We get 6x squared. These two can combine, negative 18 and positive 8. That's going to give us a negative 10x once you combine them. And then minus 24, that one doesn't have anything to combine with. So that's our final product. All right, one more. This one has 3 terms and then 2 terms, so we need a bigger box. Instead of a 2 by 2, let's go ahead and make a 3 by 3. This is likely going to be a disaster, but we're going to go for it. Oh yeah, that's what I'm talking about. This is gorgeous. I wonder how many people are going to actually watch this video like I instructed. I wish I could have put like some kind of extra credit opportunity in here or something. Okay, so 3x squared plus 5x minus 6, and then 2x minus 4. All right, same deal. We're going to go ahead and multiply everything in here. So we're going to get 2x times 3x squared. Well, 3 and 2 are going to give me 6. And because I'm doing x squared times x, that's a total of 3 x's I'm multiplying. So we're going to cube it. 5x and 2x give me 10x squared. Negative 6 and 2x is negative 12x. 3x squared and negative 4 is negative 12x squared. Here we have negative 20x and then 24. Okay, so here we're going to combine like terms. I'm going to pause recording because I don't want to run out of time. Okay, this is my final product. I got the 6x cubed and then these two combined to make the negative 2x squared, and then these two combined to make the negative 32x. So that is combining polynomials. Okay. Next, I want to do this problem because it's really going to help you with your homework quiz. So those of you that watch this video, you are officially at an advantage. So in this problem, this is going back to when we made a box. We worked with an 11 by 8.5 inch piece of paper, but now we're going to consider the situation, but with a larger piece of paper. Okay, now it's going to be a 20 by 13 piece of paper. And we're going to imagine cutting out the corners just like we did before. So this is going to be super ugly. I'm so sorry. Okay, remember, these are all identical squares, and the side length of each square, okay, is going to be considered as some length x. Remember, we had people do different sizes. So, that being said, to make an equation to represent the volume, remember volume is length times width times height. So, if we're doing this, we know that the length is 20 and the width is 13. So the new length is going to be 20 minus whatever size these two squares are. So if these two squares had a side length of 10, we would subtract 10 twice because we're cutting them off. So we represent that with 20 minus 2x. And then the other one, oh my god, 20 minus 2x. And the other one is going to be the same idea, but that side originally was 13. So 13 minus 2x. So this is the length, this is the width, and the height, when we like folded these edges up, those heights were based on the size of square that we cut out. So x is actually going to be our height. If I cut out a 2" by 2" square, the height of my box was 2. So that's our height. Okay, this is our equation. Ooh, this is rough. Okay. Lastly, if I'm going to expand the polynomial, I have to multiply these all out. I'm going to set up a box, a couple boxes. I'm going to have to get creative because I have like 3 minutes of recording time left. Okay, so the first thing I did here, this is going to be a two-step type of situation. First, I multiplied x by this parenthesis to get this. Okay, so that way we are only dealing with 2 sets of parentheses because that's the only way we can use the box. So I'm taking this and I'm multiplying it by my first set of parentheses. So I'm going to go ahead and set up my box now. I'm going to pause. All right, I've set up each parenthesis on each side of my box. So I'm going to go ahead and start multiplying out. So this is going to be 260x. Yikes, that's a little small, but that's okay. Negative 26x squared from these two. Negative 40x squared, and then 4x cubed. So we're almost done. All we have left to do now is to combine like terms. So these two are both x squared terms, and then this one and this one don't have a partner. So I'll write it in order of like highest exponent. So we've got 4x cubed, then these two, negative 40 and plus negative 26, that's a negative 66x squared. Notice how the x squared didn't change. And then plus 260x. I rewrote the equation by expanding, which means multiplying it out. Okay. All right. Best of luck on your homework quiz. And I'm gonna go make my second video.